Today we're working on Chapter 2, Lesson 2. It's called Dividing Fractions. So in our books, we should be on page 64 and have your notes open and ready to go. We're going to start with our learning target. Today it should say, I can divide fractions. So another nice short one. We do have some vocabulary, but we're going to get to it kind of in between some of the examples. The first thing we're going to talk about is what is a reciprocal. At the top of page 64, I'll read to that to you. It says, two numbers whose product is 1 are reciprocals. To write the reciprocal of a number, write the number as a fraction, and then invert the fraction. If you look down at the cups underneath that, we're talking about the meaning of the word invert. So when you invert a glass, you basically just turn it over. So if I want to invert a fraction, I'm going to take it and turn it over. So a reciprocal is when you take a number or a fraction and you basically flip it upside down. So we're going to do example 1 while we kind of talk about what a reciprocal is. So since this is still kind of vocabulary, I'm going to do example 1 in blue today. So in example 1, they give us a fraction. Then we need to write the reciprocal of that fraction. And then there's a way to check to make sure that it truly is a reciprocal. So the first fraction they give us, so this would be example 1a, is 3/5. If I want to write the reciprocal of 3/5, I'm going to invert it, which is basically meaning flip it upside down. So instead of a 3 as the numerator, we're going to put a 5 as the numerator, and the 3 is going to be the denominator. Now the way we check to make sure that this is really the reciprocal is by multiplying these two fractions. And if we get a whole number of 1, then we know we've done it right. So if I do 3/5 times 5/3, 3 times 5 is 15. 5 times 3 is 15. And 15 can go into 15 one whole time. So we know we've done it correctly because we ended up with 1 whole. We have question B. Our original fraction is 9/5. So an improper fraction. Again, the reciprocal is where you flip it upside down. So I'm going to put a 5 on the top and a 9 on the bottom. So we have 9/5 times 5/9. 9 times 5 would be 45. 5 times 9 would be 45. So I have 1 whole. And lastly for this one is example C. We have the whole number 2. Now this is not a fraction right off the bat, but we can create a fraction out of it. If we have a whole number, what we're going to do is take that whole number and put it over 1. 2 over 1 is the same thing as saying just 2 wholes. So if I take this fraction, 2 over 1, and I flip it upside down, there'd be a 1 on the top and a 2 on the bottom. So if I take 2 over 1 and times it by 1 over 2, I end up with 2 times 1 is 2. 1 times 2 is 2. And so I get a whole number of 1. So that's how I can check to make sure that these truly are reciprocals. So our main vocabulary word there that we just learned is what is a reciprocal. Go ahead and pause the video. On page 64, about 3/4 of the way down, you'll see the first 4 on your own. It says write the reciprocal of the number. Okay, for number 1, you should have gotten 4/3. For number 2, it's 1/5. For number 3, it's 2/7. And for number 4, it's 9/4. The next idea that we want to look at is how do we divide fractions? So since this is still vocabulary, we're going to hang on to this blue color. And we'll write the heading, Divide Fractions. There are some very specific steps that we take when we're dividing fractions. And honestly, we don't actually do any division, which is good for a lot of you because I know a lot of you hate division. So here are the steps. what we're going to do is we are going to actually be multiplying by the reciprocal. And we know what a reciprocal is now because we know up here that you just take a number and you flip it upside down. Once you do that, there's a little jingle that you can actually say, and it'll probably get stuck in your head. But if your elementary school teachers might have taught you something, but basically it's called same, change, flip the fraction. And last year I had my kids dancing to a little jingle. But same, change, flip the fraction is kind of the steps you would take when you divide fractions. Same, change, flip the fraction. All right. So using these steps, we're going to do some examples, and I will show you how to same, change, flip the fraction as we go. So looking at page 65 now, we see example 2 at the very top. And example 2 says, dividing a fraction by a fraction. So let's go ahead and write example 2 in our notes. The question says, find 1/6 divided by 2/3. We have 1/6 divided by 2/3. I'm going to go back up to my little jingle. Same, change, flip the fraction. So same is talking about this first fraction. I'm going to keep this fraction completely the same. So I'm just going to rewrite 1/6. The change happens when we change this sign to a multiplication sign because we're going to be multiplying by the reciprocal. So the change is going to be the change of sign. Flip the fraction is talking about the second fraction. So we're going to take 2/3 and write its reciprocal. So we're going to flip it upside down to 3/2. Same, change, flip the fraction. Now that we have this done, we can use our multiplication strategies from the previous lesson and just multiply straight across after we simplify. I noticed that 3 and 6 can actually be divided by 3. So I'm actually going to cross out the 3. And 3 can go into 3 one time. I'm going to cross out the 6 because 3 can go into 6 two times. Now that I've got those simplified, I can multiply 1 times 1 to get 1 on the top, and 2 times 2 to get 4 on the bottom. So really, when you divide fractions, you don't need to divide. You same, change, flip the fraction, and you multiply by the reciprocal. We're going to go ahead and get right to the next example. The next example is dividing a whole number by a fraction. So example 3. Looking at page 65, it says a piece of wood is 3 feet long. How many 3/4 foot pieces can you cut from the piece of wood? So if you look at these two numbers, we have 3 and 3/4. If I want to know how many 3/4 can you fit inside of the 3-foot long piece of wood, this is going to be a division question. So let's take out the information we have. We have a piece of wood. That's the word piece, by the way. That looks awful. We have a piece of wood, and it's 3 feet long. Next, we cut 3/4 foot pieces. From that 3-foot long piece. We want to know how many can we make. So essentially, we're taking the 3 as a whole, the 3-foot long piece, and we're dividing it into 3/4 sections. So we're going to do this same strategy of the same, change, flip the fraction, but we first need to figure out, what does this 3 look like as a fraction? So remember, if it's just a whole number, we're going to take that 3 and put it over 1. So this is really like saying 3/1 divided by 3/4. So if I same, change, flip the fraction, I keep 3/1 the same. I change the division sign to the multiplication sign, and I flip 3/4 to its reciprocal, 4/3. Now let's see if we can do any simplifying. 3 and 3 can go into 3 one time. And that's everything we can do. 1 times 4 is 4. 1 times 1 is 1. So this would be a whole number of 4. So how many cuts or pieces of 3/4 wood do we have? We have 4 pieces. And that takes us to some more on your own questions. The bottom of page 65, you have 5 through 9. Go ahead and pause the video and try those out. Okay, number 5, you should have gotten 6/7. Number 6 is 4. Number 7 is 1 1/2. Number 8 is 1 1/3. And number 9 is 14. Let's go ahead and look at page 66 next, where we will see example number 4. And if we take a look at example 4, it is asking us to divide a fraction by a whole number. So we're basically just putting the whole number in the second position rather than in the first position. So let's go ahead and start a new page here. I'm running out of space. So it says find 4/5 divided by 2. So we have 4/5 divided by 2 wholes. Now we can do same, change, flip the fraction, but first we need to know what 2 looks like as a fraction. So we can take 4/5 and divide it by, let's make 2 wholes a fraction. So we put 2/1. So 4/5 is going to stay the same. We will change the division sign to multiplication, and we will flip this fraction to 1/2. I see that 4 and 2 can be cut down by 2's. So if 2 can go into 2 one time, and 2 can go into 4 2 times, and now I can do my multiplication. Numerator times numerator, 2 times 1 is 2. Denominator times denominator, 5 times 1 is 5. So my final answer to this question would be 2/5. There's some more on your own. Go ahead and pause and do 10 through 13, or a couple of them if you want. Okay, number 10 is 1/6. Number 11 is 1/15. Number 12 is 5/32. And number 13 is 3/14. Last example for this lesson is example 5, and it says using the order of operations. So that tells us that we're going to have multiple things to do, but we have to decide which one happens first, which one happens second, and so on, using that same order of operations that we talked about in chapter 1. So example 5 gives us evaluate 3/8 plus 5/6 divided by 5. So we have 3/8 plus 5/6 divided by a whole number of 5. So remember in PEMDAS, the order of operations, what happens first? Are we going to add or are we going to divide first? And we have to divide first. So I'm going to basically pretend the 3/8 is not there and just focus on this part of our expression. So I'm going to take 5/6 and divide it by 5 to start with. Well, we're going to take this 5 and we're going to make it a fraction. So 5/6 divided by 5/1. We can same, change, flip the fraction next. So we'll take 5/6, keep that the same, change the sign to multiplication, and flip 5/1 to 1/5. Now I see that 5 and 5 can both be divided by 5. 5 can go into 5 one time. And now I can multiply the top numbers and the bottom numbers. 1 times 1 is 1. 6 times 1 is 6. So this part of my expression is going to be 1/6. So now basically what I have is 3/8 plus 1/6. This is now the part of the expression that I'm going to focus on. This brings us back to the 1.6 extension lesson from chapter 1, where we're going to be adding fractions, and we have to make sure we have like denominators. So if I were to use a common denominator between 8 and 6, I could use the number 24. 24 is a multiple of 8, and it's also a multiple of 6. So if I use 24 on the bottom, I have to ask myself, how do I get from 8 to 24? Well, I can multiply that by 3, which means I also have to multiply 3 times 3, and that becomes 9 24ths. Here's my plus sign. If I want to get the 6 to something out of 24, I have to ask myself, how did I get from 6 to 24? Well, I multiplied by 4, which means I can multiply the top by 4. If I do 1 times 4, I get 4. Now that my denominators are the same, I can add the numerators. 9 plus 4 is 13. And I keep the denominator the same. Now I have to ask myself, can this be simplified at all? And since 13 is a prime number and it cannot go into 24, we are finished. So after I do step 1, and then I do step 2, my final answer is 13 over 24. Go at the bottom of 66. You probably want to try one of those out just to make sure you've practiced well for order of operations with fractions. So try 14, 15, and 16 or one of those and pause the video. Okay, number 14 is 9 tenths. Number 15 is 1/3. And number 16 is 1/18. Practice starts on page 67 and goes to 68 as well as 69. So we'll pull some of those out for our online assignment. And that's the end of your lesson 2 from chapter 2.